Greetings, salutations, all those nice things. Hello everyone and welcome to lesson 6.3 where we introduce function notation. It's a new notation and it might take a little bit of getting used to, but that's okay. We're going to practice with it. We're going to see where it goes. You might recall at one point in class we talked about vending machines and we talked about blue Gatorade. And that if you press E3 on the machine, blue Gatorade comes out. Nothing else is going to come there unless something else was loaded into the wrong spot. And you can press other buttons to get the blue Gatorade, but for sure E3 gets you blue Gatorade. That machine has an input-output method behind it. There is a function. It takes input as the buttons that get pressed, and then there's output, the drink that gets dispensed. And functions are the same way. When we see something like this is read as f of x equals x plus 7. This f attached to the x is not multiplication. So we're not dividing by f, or we're not multiplying f times x. That's a whole unit stuck in a cage by itself. The x only exists as input. You don't go up to someone and say, hey, E3, without context, that doesn't make any sense. You say, oh, I need the vending machine's E3. Then you're like, oh, okay, blue Gatorade, I gotcha. What this input does is get processed by the function. The function has a definition on the other side of the equal sign over here. And that says, whatever the input is, here's what you do to it. In this case, what we do to it is take that input value and add 7. So again, that says f of x, this function of x, is to take x and add 7 to it. Again, f is not a variable. We're not multiplying f times x. We can't separate the f from the x on that side of the equation. It's kind of like, well, if we had sine theta. Oh, that's a marker. If we had sine theta, that theta only exists as part of the sine function. We don't separate them. We don't divide by sine. So that's the business there. What this does, it says that for every single input value, there's a specific way to get an output value. For every element in the domain, there is a specific element of the range that it corresponds with. That's what this function notation kind of specifies. We don't just have some general relation, we have that special case. If we want to look at something like this, where we have f of 4, that'll be the value of f of x when x is 4. That's what f of 4 means. And we can use this definition of f of x to determine what that is. So since f of x equals 2x minus 3, if we want to find f of 4, since we replaced this x with a 4, we're going to replace all of the x's with 4's. So this is 2 times 4 minus 3. It's just like this 2x minus 3, but we've replaced all the x's with 4's. From here, it's just evaluating. 2 times 4 is 8, and then 8 minus 3 is 5. So the value of f of x when x is 4 is 5. I dare you to try these other 3 on this page. See what you get. Take a couple mins. You might want to pause the video because I'm essentially going to keep talking. If you're going to pause, make sure you pause now. Great job pausing. I'm back. I'm going to do this one. What does this mean? What is f of negative 2? this is the value of f of x when x is -2. And we can find that out. Since f of x is 2x minus 3, this is like 2x minus 3. But instead of x, we've got -2. And from there, 2 times -2 is -4. -4 minus 3 is -7. So proceed with these other two same way. F of x is 2x minus 3, but x is now 8. So this is 2 times 8 minus 3, which gives us 13. And this last one, 2x minus 3 in this case is 2 times -5 minus 3, which is -13. Neat. So that's what f of x means. It takes an output, it has a defined way to process that input, and it produces some output. Somebody presses E3, and then the function says, all right, I'm going to get you some blue Gatorade. And that is what the function does. And it's really handy to think of it in terms of input-output. In these examples, we were given the input, we figured out what the output is. On this page, we are given the output. We're told what f of x is, but we don't know what x value got us that. And that's what we'd have to figure out. Now when we process that, remember that this f and this x are attached. They don't come apart. That's not multiplication. That's just a fancy notation. So in this context, that is how we have to read that. But if we want to know when f of x equals x plus 7 happens to be 20, then we just replace the f of x with a 20. If we know they're equal, one can replace the other. And then we're just solving for x in that case. Like in this case, we know that f of x is 8 minus 3x, but we also know that f of x is 14. By that reasoning, we can say that 8 minus 3x is equal to 14. It's like this is my friend Justin, and this is my friend Ian, and it seems that Justin's height and Ian's height are both equal to this Kyle's height. Well then, Justin and Ian's height must be the same thing. So that's that business. From here we're just solving for x. So I guess negative 3x is 14 minus 8. And dividing both sides by negative 3, we get that. Again, take a couple minutes, try these other 3 examples, see what you get, and then make sure you pause and then resume the video. So that's that. Wow, what a pause! All right, it's go time. We know that f of x is 8 minus 3x. We also know that f of x is negative 4. So 8 minus 3x and negative 4 must be the same thing. Okay. So subtracting 8 from both sides, negative 3x is negative 12. And dividing both sides by 3x is positive 4. I'm going to zoom out slightly, tackle these last two. We know that f of x is 8 minus 3x. That is a thing that we know. F of x is 8 minus 3x. And we know that f of x is negative 19. So 8 minus 3x is negative 19. Subtracting 8 from both sides, negative 3x is negative 27. And dividing by negative 3, x is positive 9. And final, last example, f of x is 8 minus 3x, but we also know f of x is 32. Therefore, 8 minus 3x must equal 32. Subtracting 8 from both sides, negative 3x is 24, and dividing both sides by negative 3, x is negative 8. So that's kind of all there is to function notation in this intro basis. We're going to be doing a bunch of stuff with that as we proceed with understanding functions and how they work. Hopefully you remember some of those key things. Remember that says f of x right here. And that's not f times x. In this context, that is how we read it. So you must read that as f of x. Do practice work. There's some textbook stuff. There's the worksheets. Play with those. And I will see you soon. The end.